What's happening, guys and girls? It is Sunday night here in Colorado, and I will be continuing in this video the CCNP 300-410 exam topics. We're looking at a couple of these topics, not directly any of them specifically, but pretty much we're going to be using route maps to apply them towards redistribution of routing protocols between different types of routing protocols, I should say. Right now I have a setup in EVE-NG. I just built this out today. I have RIP over here, EIGRP, Common System 100, and OSPF Area 0 here on the right. I have already redistributed routes between the different types of routing protocols, and so all the routes are learned. And the problem I'm running into, and I'm not sure why this is exactly, I can explain some of it. So when I redistribute EIGRP routes into OSPF, it sends it with an administrative distance of 170, as we learned in the previous video. So router 6 should have a route of 110 now for that route. So for example, 1.1.1.0, it's being redistributed from RIP into EIGRP, and then from EIGRP into OSPF. So router 4's perspective, it's 170 because it's EIGRP from it's an external route from EIGRP, so 170, and then it's once it's into OSPF, it's a 110 value. So router 4 is going to flood the LSA to router 6 as a 110 value, and then router 6 is going to flood it to all the other routers in the same area. So router 5 is also going to have a route. It's going to have two routes to 1.1.1.0. It's going to have a 170 route via router 3, and it's going to have a 110 route via OSPF that it learned from route redistribution from router 4. So with that being said, I'll confirm this inside the routers. So in router 4, let's pull this up here. So I do show IP route. So we're looking at 1.1.1.0. You can see it's external OSPF route, or sorry, external EIGRP route, 1.1.1.0 with an administrative distance of 170. So that looks fine. I'm okay with that. Now if I come down to router 5, this is where it gets weird, right? So it's showing administrative distance is 110 because it's a OSPF route, and that has been flooded LSA type 5, external type 5 from router 4. So I expected the 110 to take over, right? But for some reason, I was reading in the Cisco Pressbook, it was saying that R5 would also flood back to R4. So R4 should have the 1.1.1.0 route as a 110 value too, and essentially these routes would continue to be deleted and then rebuilt into the routing table. But I'm not seeing that from this viewpoint. It looks like R4 is holding the 170, it's flooding it to R5, which holds the 110 value from OSPF, which I expect that. So now the thing is, this is suboptimal. So from router 5, if I were to trace route to router 1, it's going to go router 6, router 4, router 3, router 2, router 1. I don't want that to happen. I want it to go to router 3 as the next hop. So what I'm going to do is I'm going to use a route map to make this happen. So first thing I'm going to do is I'm going to go in, I'm going to say IP. I'm going to use a route map, but I'm going to tie it to a prefix list. So I'm going to go conf t IP prefix list, and then we're just going to name it. I'm going to say use EIGRP because we want it to use the 170 value, not the 110. So I'm just going to name my prefix list use EIGRP. Put a sequence number of 10, and we're going to deny the 1.1.1.0/0/24, just like that. I'm going to do the same thing, but I'm going to put a secondary that allows every other route. So permit 0.0.0.0/0 less than or equal to 32. So this is everything between 0, 0, 0, 0, and I guess 255, 255, 255, 255. So that's going to allow everything. So now that we have this prefix list, we're going to make a route map. So we're going to go route map, and I'm going to name this filter. And let's see what we got here. Permit 10. I think it's sequence number next. Sequence, yep, 10. And then what we're going to do is we're going to say match IP address prefix list. And then this is the name of our prefix list, which was use EIGRP. So we're building a route map that's going to essentially match to the denying the 1.1.1.0 and allowing everything else. So now that we have this, I'm going to go to router OSPF 1. So we're on router 5, and what I'm doing is I'm going to go into the OSPF router OSPF 1, and we're going to distribute list, and this is going to be route map, the name of the route map, and then the direction, so in. So what I'm saying here is on router 5 inbound, I don't want anything as far as OSPF goes. I don't want anything to be learned from 1.1.1.0 on the OSPF side. Everything else is cool. So when the 1.1.1.0 subnet traffic comes through, gets redistributed from RIP into EIGRP and then into OSPF, it'll get flooded through OSPF area, but router 5 is going to say, I don't want to learn that route, that external route that you're giving me. So that's what this filter list is doing. So we'll go ahead and exit. You can just hit end as well, and then it'll go back. So now I do show IP route. I'm hoping to see 110 as the value. Still shows one. Oh, sorry, I want to see 170, right? Because we want to use the EIGRP route. We don't want to use the OSPF. So now it's showing my next hop is, in fact, 10.3.3.3, which is router 3's interface IP address. So everything's good here. And then just to confirm route, nothing happened to router 4. Should still be the same. Show IP route. Should still show. Oh, so you see what happened here? They flip-flopped, right? So now this is 110. We want this to be 170. So I'm going to go in and do the same thing on router 4 to force it to use the 170 metric. So we'll go conft IP prefix list. What do we call it? Use EIGRP. And this is sequence 10 deny 1.1.1.0/24. Go in, do the same thing, sequence number 20. Permit everything else from being learned. And then less than equal to 32, so all the routes. So then we go in and we go route map, and we will call this filter. And we're going to say permit 10, and then match IP address, so prefix list, and this is the use EIGRP. Okay, we're good there. Then we're going to go router OSPF. Same thing we did on router 5. Router OSPF 1, and it's going to be distribute list. Distribute list. The name, so route map, and the name of the route map, which was filter, and then inbound. So let's see what happens here. So we're going to show IP route. So we want to see 170, which we do. So it's back to 170 via router 3, 10.3.1.3. Let's check router 5 and make sure it kept. And it did. So both router 4 and router 5 are using router 3 as the next hop to get to 1.1.1.0, which is what we want. And that's essentially all I'm going to cover in this video. I honestly need to do a little bit more research on route maps before I go into some of the other characteristics, looking back at the exam topics. So let's see, 1.2, troubleshoot route map for any routing protocol. Attributes, tagging, and filtering. So before I do that video, I need to read up a little bit more on these features. I know you can set, like with tagging, you can set like administrative distance, things like that. So I need to go through and just do some research on that before I put out a quality video, or a better quality video, I guess. Troubleshoot loop prevention mechanisms. So we kind of just did prefix list. So that's a way of filtering, essentially. So kind of go through some of these other ones, another video. Troubleshoot redistribution between any routing protocols or routing sources. So we did just do this. So there was some redistribution issues going on. As you saw, it was preferring the OSPF routes as over the EIGRP 170 administrative distance routes. So we were able to apply a route map that called a prefix list that matched specific IPs and said, hey, I don't want to learn any sort of routes on OSPF from external routes from this IP via OSPF, and we applied that. So we actually got a solution using route maps. So hopefully this was informative. Like I said, I'm kind of learning this as I go along. Spent a couple hours today labbing this up, trying to understand it a little bit better. But if you like this video, please subscribe to the YouTube channel, and like me on Twitter. It's Technology Training, and thanks for watching.